Hi everyone, this is S. Venkatesh. Today we're going to discuss basic instruction types in computer organization. Let's get into the topic. There are four types of address instructions: zero address instruction, one address instruction, two address instruction, and three address instruction. A computer performs a task based on the instruction provided. Instruction in computers comprises groups called fields. These fields contain different information as for computers everything is on 0 and 1. So each field has different significance based on which a CPU decides what to perform. The most common fields are operation field specifies the operation to be performed like addition. Address field which contains the location of the operand, that is register or memory location. Mode field which specifies how operand is to be found. And instruction is of variable length depending upon the number of addresses it contains. Generally, CPU organization is of three types based on the number of addresses fields. First, single accumulator organization, general register organization, stack organization. That the operands in instructions can be stored in the accumulator and general register organization or stack organization. In first organization, the operation is done involving a special register called accumulator. So in second on multiple registers are used for the computation purpose. In the third organization on the work on stack basis operation due to which it does not contain any address field. Only a single organization doesn't need to be applied. The blend of various organizations is mostly what we see generally. So the result of the instruction can be stored in any one of these three registers. Accumulator, it can be or can be general register or it can be stored or stack organization. And next, first, zero address instruction. So uh, in the stack there are two operands A and B. And first we have to push A, then the top of the stack will be A. And next push B, then the top of the stack will be B. Next, for we have to do operation like multiple operation, then the stack of the top of the stack will be the result of the operation. A stack-based computer does not use the address field in the instruction. To evaluate an expression for first, it is converted to reverse Polish notation, that is postfix notation. For example, the expression could be x equals to a plus b into c plus d. Then the expression of the postfix will be x equals to ab plus cd plus and star. Top means the top of stack. M of x is any memory location that would be address maybe 100, assume like 100, 200. That's the and next the operation will be continuous as follows. For the before expression, first we have to push A to the top of the stack, then the top will be equals to A. Next push B, then the top of the stack will be B. And we have to perform operation, add operation, then the top of the stack will be become the result of the operation A plus B. And the next push C, then the top of the stack will be become C. And the push D, then the top of the stack will D. And next do an operation to the top of the stack, and so the top of the stack will be C plus D. And next multiply the operations C plus D and A plus B. Then pop the result of the multiplication. So it can be stored, the top of the stack will be result of the multiple operation. The next one address instruction. This uses an implied accumulator register for data manipulation. So the result will be stored as in the accumulator. So which is this and one operand is in the accumulator and the other is in the register or memory location. Implied means that the CPU already knows that one operand is in the accumulator. So there is no need to specify it. So additionally, it did not specify the accumulator. By default, it will be mentioned in the instruction. The syntax will be as follows. First opcode, that means operation code, and the next operand or address of the operand, and the next one is mode. For example, take an expression x equals to a plus b into c plus d. As we explained it before, the one at zero address type. So here AC is an accumulator. Mm, where M square brackets is a memory location, M of T is a temporary location. So the above expression can be divided into number of steps as first load A into the accumulator as M of A. Next add B to the accumulator. So the expression will be the instruction will be become AC equals to AC plus M of B. Next store the accumulator into the M of T, which is a temporary location. So store the accumulator in the temporary location. The next step will be load C. So load C value into the accumulator. So after loading the C value to the accumulator, next add D value to the accumulator. So now the result will be accumulator plus M of t. The D value can be get it from the memory location by knowing the address. Next, the next step will be multiplication. So in assembly language, it can be written as MVLML, and next, the t value can be multiplied with the accumulator. So the result will be AC into M of t. It is an temporary location, and then store the x value into the accumulator. So sorry, store the accumulator into the M of x. And the next one is two address instructions. This is common in commercial computers where two addresses can be supplied in the instruction. Unlike earlier in one address instruction, the result was stored in the accumulator. Here, the result can be stored at different locations rather than just accumulators. So, before we have seen the result will be stored in the accumulators. So, in two address instructions, the result can be stored in the registers itself. So, but require more number of bits to represent address. So we can to store the results. We need to have a number of registers. So the syntax will be as follows: operation code, destination address, source address, mode. But before we have seen that two address can be, one address instruction can be syntax will be op code, uh, only one source code and mode operation. But we have seen their destination address and source address and mode operation. Next, their destination address can also contain operand. We have taken the same example as before. We have taken the for the one address instruction and two address instruction. Here the expression could be x equals to a plus b into c plus d, and so the we can get the uh, destination address and uh, source address from the R1 R2 registers, and M square brackets is any memory location. So the expression can be divided into number of steps as mentioned I have there. Move first the first step will be move R1 comma A. So the A value will be moved to the R1 register. So the equation can be R1 equals to M of A. And so we have taken the A value from the memory location. So it can be represented as MFA. Next operation could be add R1 comma B. So add B value to the R1. So the instruction the step can be R1 equals to R1 plus MFB. So we have fetching the B value from the memory location as M of B, and move C value to the R2 register. So it can be mentioned as R2 equals to C. Next step will be add. Add R2 and D. So D value could be added to the R2 register. So the instruction can be R2 equals to R2 plus D. And the next one is multiply R1 register and R2 register, and the result can be stored in the R1 register. So R1 equals to R1 star R2. And the next step can be move X1 comma R1. So move the R1 register to the into the memory into the X, which can be stored in the memory location. So it can be represented as MFX equals to R1. And the next instruction could be three address instruction. This has three address field to specify a register or a memory location. Program created are much short in size, but number of bits per instruction increase. These instructions make creation of program much easier, but it does not mean that program will much run much faster, because now instruction only contain more information. But each micro operation changing content of register, loading address in address, bus extract, etc. will be performed in one cycle only. But before we have mentioned that two address instruction, one address instruction, some instruction maybe have complex instruction, but it could be take more time to decode it. But some instruction may be simple instruction, but it could be take less time. Uh, the syntax will be opcode, destination address, source address, and mode. Before we have seen the in two address instruction, there will be only one destination address and one source address. But now we have two source addresses, so it can be complicated. Expression can be take x equals to a plus b into star f c plus d. So there we have taken R1, R2, R register to store the to store the arrays are manipulating the memory address, and m square base is any memory allocation. This can be taken as uh, so the first instruction, the first step can be add R1 comma A comma B. So add A value and B value to the R1. So fetch the A value and B value from the memory location as M of A plus M of B, and add it to the R1 register. Second, add R2 comma C comma D, and fetch as is fetch the data of C value and D value from the memory location and add it to the and the result will be add to the R2 register. And the second and the third step will be multiplication. Mul x1 comma R1 comma R2, and first multiply the R1 register and R2 register, and the result can be stored in the X value. So M of X equals to R1 star R2. And thank you.